Hey, hey, welcome, welcome.
Hello, Professor.
Hi, I'm gonna have to turn up my volume a little bit. Let's see, where is it? So I spent the last 15 minutes trying to get logged into WebAssign with no success, which is not great. I had it all figured out, so we'll just have to jump into lecture mode. All
Well,
right,
sounds like the
first
first class.
off, what I'd like you to do is open up the chat if you can find it. I have to find it as well. There it is. And just type here or maybe your first and last name, just in case the name that shows up isn't the same. Here, I'll even put that here, or your first and last name, basically just for attendance. And we'll just do that automatically if you can remember at the beginning of each class to just type hi or here. And after today, you don't really need to type your name because I can figure out who is different than, looks like y'all match. Sometimes people are using somebody else's machine or something, and I can't see who it is unless you tell me. All right, great. So hopefully you all have looked at the syllabus addendum. Maybe I'll go ahead and quickly start by going over a couple things. So I'll share my screen and we'll go right to our class. Let's see, I guess I'll try that. So here I was, I logged in and it says I don't have any courses. So I'm gonna have to fix that because I definitely have a course. All right, so we'll go to, actually my other browser is what I wanna share. Sorry. I have one for my College of Charleston logins and one for my TTC logins. So let's try sharing this other one. There we go. All right, so here's our homepage. And as people keep coming in, just go ahead and type your name or here in the chat so I can count you as here. And just want to make sure that everybody's seen and hopefully read the syllabus addendum. It's posted here as an announcement. But since you can close these announcements, I also have it under content. Content is more static. I can add things and they stay there and you can always access them. So under syllabus here, I've got the departmental syllabus, which is just your general information about the course, and your syllabus addendum, which is all the specific stuff about this course and how we're meeting on Zoom and how you need the WebAssign part, at least, of the textbook. If you've got if you get the packet, great. You've got the loose leaf paper as well. It's great. The WebAssign, I believe, comes with an online ebook as well as the homework. And so I've answered a few questions about, why am I asking you to purchase that? I think it's worth it. It's $100 if you just get the WebAssign code, but it's one of the biggest things is that it can check your answer in many different forms. And you probably know as you get higher in mathematics that expressions can have many different forms. And simplifying an expression is a little bit more subjective than maybe it was back when you had simpler expressions. So, so I just gotta email of someone wanting to be added to this course. We'll have to work on that later. This course, this lecture is automatically recorded. Want to make sure you know that. Hopefully you got some notice that it's recorded. That's so that I can post it later. And you can always go back and watch any part that you've missed or need to rewatch, or if you are unable to attend, you can watch it later. So that's one real plus, I think, real perk we have, I think, being having our lectures in Zoom, is that it's easy to record and it's always there for later in case you you need to have a rewatch, you know, in case you don't get something the first time around, which can happen.
Thank you.
Yeah. So that'll always be posted. But yeah, so if someone isn't able to attend tonight, they can always watch the lecture later. All right, so we've got that. We've got the WebAssign. What I was talking about there is people are still coming in. This is great. The WebAssign software is great for checking your homework. Otherwise, really, you know, it's just like problems out of the book. These problems are real similar. Well, there's another added advantage in that it can generate probably an infinite number of similar exercises just by changing the numbers, and you get a similar exercise that's basically solved the same way. So when you're doing your homework, I think it's probably a 3 strikes and you're out type of system, but you should be able to do these problems over and over again so that you can eventually get 100% just by persistence. And hopefully that'll help you to learn as well. So yeah, so it's got generating different problems. It's got check your answer ability. You know, sometimes it's hard to check your answer in the back of the book if you've got it in one form and book has it in another form. So that's a real perk. The other thing, depending on how this goes and what feedback I get from you, so feel free to give me feedback. I'm thinking I will actually create your tests in WebAssign, so that you'll be able to access your tests. Everybody will have some different numbers. It'll be pretty much, you know, same type of problem, but different numbers. And you do your test and it can correct them. And then I can check your work to make sure that you know, have supportive work, which is going to be a requirement. So yeah, so make sure that you get that code and get it going. I obviously have to have some work to do. I was even sitting down with the WebAssign Cengage representative, and she helped me get your course up and running, and now it's disappeared. so I'm gonna have to find that. Let's see. So I've got a bunch of stuff here about, you know, doing the homework. There's a lot of homework solutions by previous instructors of this course, as well as myself in content. There's a bunch of stuff under content here for you to have for resources, some of which I'll pull up and use with our lectures, and some you can just look at on your own time. Typically the class notes here from Mr. Flenner, I tried to pull those into a separate kind of module here so that you can look at those if you want to. And then I'm going to make a separate module for class recordings. I actually have old class recordings here that I have hidden that I'll probably turn on from last spring when I taught this class, and we had to go online abruptly in March when the pandemic first started. So I've got those there that I'll open up, but from now I'll set up our own module of class recordings for our classes starting tonight. So let me stop for a minute and see who all is here. Y'all are so shy. Anybody want to show your face so I can actually see what you look like? Got a few people. Hi. There is a Jonathan Powell. Where'd you go? I know someone named Jonathan Powell, and I was curious as to what you look like. Where's Jonathan Powell? What do you look like? He's going to be shy. Some people don't have webcams. That's fine until the first test. Okay, for taking tests, you're going to need to have that webcam. So either find one, borrow one, buy one. Yeah, there's all kinds of tech things that. Okay, so you have to purchase WebAssign. I mean, Cengage is the company. The textbook does not have WebAssign. Okay, so the textbook is the textbook, whereas WebAssign is this software that generates homework problems and has due dates and a grade book and all kinds of things. So WebAssign is a separate thing from just the textbook that you can get, you know, hard copy, loose leaf, Kindle. So you do need the WebAssign code and that that particular product. Okay, so yeah, yep. All right. Other questions, either verbally, you know, if you keep yourself muted, that's great, so that there's no background noise. But do y'all know that if you press the space bar, you can speak? It unmutes you while you press the space bar. If you have a question, you can do that. Just press the space bar and ask your question. Yeah, there's some good comments here in the chat, y'all. Thanks. Good experience from. What's the best way to go? Just get the $100 code. Yeah. I mean, it's still $100 code is still less than, you know, what we've paid in the past for upper math textbooks. I remember my mathematics textbooks being closer to $200. So it's, believe it or not, not actually that expensive, relatively speaking. Any other questions? Let me go back to sharing.
I did have a question.
Yeah.
The camera exam software for our test, does that camera require a scan of our work area?
Okay, so that I'm thinking I'm just gonna do kind of with everybody at once, just kind of a quick, everybody show me your work area, you know, just a point your camera towards your desk area in front of you, and then I'll basically just say, okay, everybody start, but I want to be able to, you know, see you all while you're working. It's not going to be as good as, you know, like, what are those Proctor softwares, Honor Lock and Respondus, you know, it's just going to be, we're all here in Zoom and you're all taking your test. And then when the test is finished, regardless of whether it's on WebAssign or on paper, the paper part of the test, you're working out the solutions, is going to be really the part that I want to see. If we have if I create the test in WebAssign, that's just going to be for you to put in your answers. And as you'll see, the answer is really the least part of the problem. The process is the main thing that I want to see and grade. So the way, let me go back to, I was getting ready to share. Let me go back to the syllabus addendum so I can address this.
Yes, because Honor Lock is absolutely horrible.
I agree. Oh my gosh. Yeah, in fact, and it's expensive. And so we've actually decided not to use that as a school. Cal, why is it? There we go. Share. Nope, that's the wrong one again. I think I'll just go screen 2 so I don't have to worry about what I'm actually showing on screen 2. All right, can you see
Yes.
D2L here? Good, good, good. All right, so back to this. The assignments are, in WebAssign. There's book assignments as well. If you have the book and want to do extra practice, the more the better, probably. But yeah, we're going to have 4 kind of unit exams where the material is divided up into these 4 units, and those I was going to just have them be print out. I was just going to post the questions, and basically you would just do the test on paper, and really, if I put it in WebAssign, like I said, it's going to be the same thing. What you're going to do is you're going to have a bunch of paper, and you're going to write down the problem, and you're going to work out the problem, and then either put a circle around your answer or enter your answer into WebAssign. Okay. When the test is finished, when you're finished, you're going to want to scan your work, okay? And there's different options for that. If you have a scanner, obviously great, scan it and upload it. And you're gonna upload it to the assignments. Let me open that in a new tab. The assignments, what do you call this? Drop boxes. And it looks like I've got to put in test 1 and test 2. This I had just from last time I taught this. Again, we got caught in the middle. But there'll be a test 1 and a test 2 in class folder and take home problems folder for you to turn in both take home problems, which are just problems that I'll post and have due on test day. I'll post like a few days beforehand, and you'll have a few days to do that. Maybe even a week. If I can give you a week, I will, to do some problems that are a little harder, take a little longer. The in-class problems will be problems that I think that you can, do within a 2-hour time frame. So you'll scan your work either with a scanner that you have or with an app, a scanning app on your phone. Apparently iPhone comes with one. So I had some instructions that my class yesterday gave out in the chat to the class, which I'll probably copy and post, but I have some other instructions under content. Maybe not. It's in my other course. Okay, I guess I decided you guys were at such an upper level that you can figure it out yourself. But you just want to find a free scanning app. There's like Cam Scanner and Adobe Scan and Microsoft Lens. I'll copy over that module. Let me write that down. Copy over a module that's got instructions on scanning, because I don't want you to take pictures of it. To take, a picture of each page and post it is just, no, don't do that. The scanning apps allow you to scan more than one page at a time. I mean, it still works just like a camera. It's still, you open it up and, click the button, and go to the next page, click the button, but it saves it into a, several page, one file, a PDF file document that you can then upload into the Dropbox. So that's the way to go. So tests, we'll just, we'll be taking them in Zoom, like as if you were taking them in the classroom. You are going to be on your honor as far as not using any outside materials, taking the test while in Zoom, and having your video on should keep you from having someone next to you helping you. So
Well,
yeah, there's what's that?
My 4-year-old will probably come up and try and help me.
Oh, that's okay.
All right. Yeah, she's looking at me right now.
A child, well, she's a she. Is it she?
Well, yeah, 4.
Yeah, well, she's a child prodigy and knows differential equations. I can't allow that.
Come on. But she's cute though.
Oh, well. All right, we'll make an exception. No, but so the Zoom environment is going to be our classroom, and you are going to be on your honor not to use any outside resources, except to kind of help everyone out and put us all on a level playing field for the one or two people who might want to try to have some notes handy anyway. I'm going to allow everybody to have one page, one-sided one page of notes for each test, okay? So everybody gets that one page, one-sided, handwritten page of notes that you can use during each test. And then you will just scan that together with your work and post it together with your work in the folder. I'm hoping that that will be enough for you to feel like, okay, you know, you've got what you need, and, you know, you can learn and should learn, obviously, everything beyond that. So yeah, that's in the syllabus. Where'd I have that? Here. So these are tests are going to be taken during our regular Zoom sessions. They're on the calendar. You are going to have 2 hours to complete the exam, and then you're going to scan it to a PDF file with a scanner or a free phone app like Cam Scanner. Then you're going to put it in the appropriately named Dropbox under assignments. I should put that in there. But these for each of these in-class timed exams, you can have a single one-sided page of notes or formulas that you can use during the exam. Must be handwritten, must be in your own handwriting, turned in with the rest of your test work. And with your test work, make sure you copy the exam questions. I'm going to be posting the exam. In fact, I'll post the exam on the folder, in the folder. So when you go to assignments, and you click on the test one in-class folder, you'll actually be able to pull up the test, okay? So that then you can just copy it down, copy the problems down onto your paper and do them. So they won't be there, of course, until it's time to do them. Ding dong. People coming and going or just coming? I should turn off the ding dong. Where's that? I have to stop sharing to do that. All right, let's see. I need to go to the 3 dots under participants and uncheck play sound. There, that'll help. All right, we got a good class. I was surprised to see that this is my biggest class. Usually DE is a smaller class. That's great. All right, let me go back to here. So, where is the syllabus? There it is. Oh, I lost it. I keep closing things without meaning to, sorry. All right, so I want you to write at the top of your exam or at the end of the exam, either way. Do you see this statement? I'm having a hard time highlighting just a little bit at a time. That you have neither given nor received help on this exam, just kind of an honor code statement. I want you to write out and sign your name, stating that you're, you know, being on your honor and doing your own work. So yeah, that's the deal with that. And then these exams count as 70% of your course grade. The departmental final will be 25%, and the homework is going to be the other 5%. So any questions on that? All right, calculator, hopefully y'all have a TI 83 or 84. If you've got an 89, that is allowed and encouraged in this course. It's got some neat things that'll really help you. There's some of the techniques we're going to be using, like partial fractions, it'll do automatically for finding antiderivatives using partial fractions. And what else? I can't think of them right now, but as we come to them, I'll show you. And I've got a nice handout, well, document. Under general information, there's a bunch of general stuff, and one in particular is using the TI-89 in this course. So we're going to start with some integration review. Last call for questions on logistics.
I have a question.
Yeah.
You said that we needed Cengage. Why do we need Cengage? Is it because it has like the book, ebook?
No, it's because it has the homework and test system that generates infinitely many different problems for you that are all of the same type. And that's where you'll do your homework, and you'll be able to get credit for your homework. And that's also where you'll have at least one test. I'm going to try at least one test that'll be out of WebAssign.
Okay, thank you.
Any other questions? Yeah, keep in mind, Cengage is the company name, right? Zill is the author of the textbook that is made by Cengage. Cengage also makes the product called WebAssign. Okay, so the WebAssign product is this robust problem generator and grader, and that's really something. So that's the product that we're going to use and hopefully enjoy. But the textbook, of course, is either print or Amazon or Kindle or just online, that or loose leaf, whatever. That's different.
Dr. Champagne, you have a second?
Yes.
There's a bunch of questions in chat people are asking, just in case you've not seen them.
Thank you. Let me stop sharing so I can see that. All right, so dang, someone's question. Okay, homeworks. Okay, due dates. So that's in the syllabus as well, and should show up in WebAssign. When you get logged into WebAssign, you'll see the due dates. That's another thing that WebAssign does, is I basically choose the problems and assign due dates to those problems. But there's a calendar at the bottom of the syllabus addendum, and I'm not sharing it right now. Let me do that. Oh, it doesn't say. Where does it say? It doesn't say on the calendar. It should say here. Blah, 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 blah. Blah, blah. Doesn't say. Well, I neglected to put that in there. Anybody see when the homework's due? Okay, well, I'll tell you. it's in WebAssign. But your homework will be due on the day of the test. How's that sound? So all of the first unit's assignments are due on February 2nd. Okay. All of Unit 2's assignments are due on March 18th.
Wait, there's a test on my birthday?
Oh, I'm sorry. That sucks. Well, you can go out afterwards and celebrate.
Yeah, for sure.
All right. Let's see what else. Yeah, so each test day is going to be when the assignments for that unit are due. So you can pace yourself. And notice we have a long spring break. I don't know why they did that. They gave us 2 weeks. The Monday, March 1st is a class day, but that doesn't affect us. So we actually get 2 weeks of spring break right in the middle of our second unit. So you can have plenty of time, hopefully, to do the homework for that unit. The last unit is real short. But that's how that's going to work. And I'll work on making that clear. So I might have put it on your calendar in D2L here. I was trying to do that. No, I just have a Zoom class test 1. I have your tests on the calendar. So if you can just remember that when the tests occur, that's when the homework is due. And, you know, basically I would strongly recommend that you try to keep up with the homework according to what we're covering in class. So this calendar in the, oh, where'd it go? Lost it again. Dang it. I waste so much time on this stuff. The classroom, I missed the classroom because it was just so much more efficient. All right, so the calendar, I think, shows you what you should do when, okay? So the ultimate, when it has to be done, has to be perfect as you can make it, is test day. But what you really need to try to do is keep up with the calendar, right? So we're covering the first, the 2 sections in chapter 1 tonight. Try to get those done, the problems for those 2 sections, before Thursday, so that you've got it and you're down and you're ready to go on. Also, because as you know, each class day's material is going to build on the previous class day's material. So take advantage of the fact that we're in a full term course and you have time between classes to work on things. You only have to work on, a section or 2 at a time. So that's really nice. I actually learned this stuff in the fast forward format, and that was tough, I tell you what. So you've got time to work between classes. Try to use it and do the homework. Get into that WebAssign. There should be, most of these things give you a free access. I think you do get a 1-week free access. So if you have to pull together the funds for it, you've got a week and you can still go ahead and get started right away. And Thursday, I'm going to pull that up and show you kind of more about WebAssign, but I can't tonight, unfortunately.
Wait, I have a question.
Mm-hmm.
Are we supposed to buy? Are we supposed to buy an account or buy subscription?
Yes, buy a WebAssign account. Yes.
How much? $100.
$100. Okay, I believe you can get that here. I meant to send you that. Yeah. So you want to get the Cengage Unlimited e-textbooks if you want the e-text. If you want the textbook, I believe you need. Yeah, to get WebAssign, you need to do the Cengage Unlimited. So you can start the free trial and then oh, it's just asking me to sign in because I've done that before, but it should, create account. There we go. So then you say you're a student, you put in your email. Let's try this. Let's see what happens if I put myself in as a student here. See how it does. So you go in here. Oh yeah, I already have an account. Duh. All right, let me put my Comcast. Let's see what it says. Oh, what? Oh, that's weird. Look at that. It still says that. Okay, let me go back. Here, I'll use an old one. I used to be Jane West until just almost a year ago. I got married. So we'll try this one. See what it says. Okay, so then you got to fill in all this stuff, blah, blah, blah. All right, I'm not going to spend any more time on this. So just do that and sign up and you'll be good. There should be an option though for getting that free access initially, but eventually, yeah, you're going to have to fork out that $100. Sorry.
That sucks.
Oh, School costs money, but it's not going to suck as much as actually learning this material. No. No, this is tough stuff. I mean, you're gonna need the help that'll give you. In fact, that's the other thing, is that there are, help tools in these homework systems that, if you've used any of these products before, my Math Lab or Hawk's learning system, there's a lot of help tools. Help me solve this types of things, show me a similar example types of things that I think you're going to find really helpful. Okay, we need to move along, don't we? But I do need to see what other questions there were. Sorry. You will ask for payment. What's that?
Yes, ma'am. So I'm kind of confused. Do we need so I know we need web assigned, but do we also need to buy the textbook?
That's optional.
Oh, okay. Thank you.
Yeah, you're welcome.
I got another question as well.
Okay.
Is there a limit on the size of the paper for the test? Like the size of
Yes. Oh, nice try. 8 by 11. 8 by 11.
Okay.
I better put that in there, huh? You have this huge sheet of paper.
Yeah, I was scheming. All right, never mind.
Oh dear, you won't need that. No, and ideally, everything on your piece of paper you actually will know. It's just that, in a test situation, when you get nervous, then it's sometimes harder to recall it. So you'll have it there. So you can kind of think of it as a comfort blanket, but you really should, try to learn everything that's on your paper. All right. I logged into WebAssign test day. Good. So there's a lot of good comments in the chat. Any other questions? Oh, Cheryl was making all the ding dongs. No problem. Yeah, and I do suggest that you buy the textbook as well. It's not that much more. I think it's like $46, $47 more if you get the textbook as well in loose leaf form. At this level of mathematics, you should be at least starting to take advantage of reading your textbook, being able to look through the examples. And I'll do that too in class. That's one reason I'm frustrated that they don't show my account on that I have this class in there, because I want to be able to show you things in the textbook as we go along. It's not going to be as necessary for this first day, thank goodness. But I will refer to the textbook, and it would be nice if you can too. Yeah, if it didn't ask for payment, don't worry, it will. Poster board. Yeah, no. Oh, goodness. Anything else?
Someone asked if
Yeah, how one more thing. I already logged into my Cengage account. I just want to know how to enroll in your class.
So there is a code, an access code.
Yeah.
And here it is, WebAssign class key. I'm not sharing right now. Let me show you. It's on the syllabus, and it should be on the announcements as well. But it is right here. Do you see it? Trident Tech. Whoops. This one right here. Oh, I can't highlight just that. There we go. Almost. Trident Tech 1303-1387 is going to be the class key that you'll enter when prompted. Okay. All right. Yeah, things are always a little.
Someone mentioned that the code provided isn't working for them.
The class key?
Yes, that's mentioned in the chat by one of us.
That is a problem. So I will check into that. Has anyone, on the other hand, it sounds like some people have been successful getting in and seeing assignments?
Ours worked.
Okay. So keep trying.
Yeah, it worked for me. I was able to start
Okay,
some of the
good.
homework and all that.
Awesome. Awesome. All right. So yeah, keep trying if it's not working for some reason. The 2-hour limit on the test does not include scanning. The scanning needs to be done within 15 minutes of finishing your test. So if you're, just finishing at the end of the class, that's okay. You can scan afterwards. Okay. All right, so let me think how I want to do this. I have one of my screens is touch screen. So what I want to do is use that to lecture with. So that'll be kind of like my whiteboard. And that way, my lecture notes, what I write down on the whiteboard, will also be posted in D2L so that you'll have not only the video recording of the course, but my notes. So I meant to start that ahead of time, of course, ran out of time. So I'm going to start my notes. You can tell I'm from Minnesota when I say notes, can't you? So I'm just going to start one note. And I'm going to share. Oh, where's my Zoom? Where's my Zoom meeting? There you are. I'm going to share this screen. And I apologize for some initial kind of sketchiness as we all get used to this. All right, so this was just testing. So now what I want to do is start a new page. And actually I've got a course created here in an online space. So I'm going to go to our content library and insert. How did I do that now? I want to add a page. Okay, here we are. So then what I can do is close that off and go to full screen. Well, that was full screen, wasn't it? All right, I guess I could unshow that, but maybe I don't need to. I'll just leave it. All right, so what I'm going to do is turn this upside down. So if you're looking at my picture and the camera, of course, what you're going to see is the ceiling. But today we're looking at sections 1.1 and 1.2. And actually, I need to also, depending on our time here, what time is it? It's almost 6 o'clock. We're also going to review some integration. All right, so the other thing I'm going to be doing is pulling documents over here from the D2L website that we can use over here that I can write on to go over these various things. But first of all, let me just give you kind of an intro to differential equations. Differential equations, there's two types. There's ordinary differential equations and partial differential equations, ODEs and PDEs. ODEs, ordinary differential equations, involve ordinary derivatives like dy dx, which of course is also written as y prime, or d2y dx squared. Why are the twos in different spots? Do you know that? That's basically the derivative with respect to x of the derivative of y with respect to x. So if you look at this, what do you have? You have two d's and 2 dx's. So the 2 goes after the d on top, whereas it goes after the whole dx on the bottom. So in case you ever wondered why those 2's are in that position, that's basically why. And then for higher derivatives also, d3y dx cubed is the derivative with respect to x, right? That's an operator of the second derivative of y with respect to x, right? So then you can see, okay, now there's 3d's and 3dx's. And of course, this is also in shorthand or in other notation, just y double prime and y triple prime. And of course, if you go to the fourth derivative of y with respect to x, that's, same thing here. That's not y with 4 tick marks, right? At this point, they start using the upper 4 notation, where it's in parentheses to distinguish it from powers. So we're going to be dealing with ordinary differential equations. So this is a course in ODEs, which we're just going to be calling, I'll just say called DEs, differential equations. PDEs deal with partial derivatives, and those you studied if you took Cal 3. If you haven't had Cal 3, that's fine. I will remind you all you need to know about partial derivatives, but that's where you have this curly thing, the partial derivative of y with respect to x. Although usually,
I'm taking that class right now.
Oh my gosh, that's great.
Yeah.
So usually the partial is going to be of z instead of y, because you've got z as a function of both x and y. And so you have the partial derivative of z with respect to x, or the partial derivative of z with respect to y, where you're holding one variable constant and taking the derivative with respect to the other variable as your variable. So this is where it gets really important, which variable you're taking the derivative with respect to. But that's going to be important for us too, because sometimes x is going to be your independent variable. Sometimes t will be your independent variable. All right, so we're going to deal with the ordinary differential equations. There's 4 units, and let me just kind of break down, the gist of each unit. In unit 1, we're just going to be looking at first order differential equations. And that word order, we're going to look at what does that mean. And order is really just going to correspond to the highest derivative in the equation. That's really all it is. So I don't even need to define that anymore. It's the highest derivative in the equation. So if you have a second derivative in the equation, then it's a second order differential equation. And by the way, a differential equation is just an equation that involves derivatives. Okay, so nothing fancy there. If you want to see more, this is where having access to the textbook would be helpful. Where if you want to see, more about what's the technical definition.
Not at all. You made this a lot easier in the first 4
what's
pages.
The existence theorem that I'm going to show you. If you really want to dive in, then you need the textbook. Otherwise, I'm going to give you just, the just what you need. So we're going to look at what are sometimes called recipes for solving first order differential equations. And what else? We're going to look at a few applications, which, to tell you the truth, are my least favorite part of this course, because I am a pure mathematician. I took physics back during my freshman year of college, when I thought I wanted to be a medical doctor, and didn't enjoy it. But I went on to, you know, to get all these degrees in applied mathematics with computer programming, and then pure mathematics, which is just really just mind games. But I never have really liked the applications. It's kind of funny. All right, Unit 2. Oh, by the way, the applications are going to be where the take-home problems come from. The problems where that might, you know, require a little more time, where you're still not supposed to, you know, get help from, definitely not help from a tutor or instructor, but you can still work together on them if you want. Everybody just has to turn in their own write-up. Unit 2, we're going to look at higher order DEs. And we're going to look at some more applications. And I have a call coming in on my office phone. Huh. Interesting. More applications. Yeah, I'm in my office here teaching you guys. All right, so we've got some more applications and higher order DEs. There's going to be different types that we're going to look at, and then different recipes for solving. And I am going to need to close my office door. Hang on one second. All right. Unit 3 is going to be dealing with something called the Laplace transform, which is a really interesting piece of work, piece of mathematical work for transforming equations and allowing them to be solvable in a different form. So it's called the Laplace transform, and we're going to use that to solve what are called initial value problems, which you've probably dealt with before. We're going to look at some of those and what an initial value problem is in this first unit as well. But the Laplace transform can also be used to solve these initial value problems. It's really cool. And then there's more applications to circuits in particular. If any of you have taken engineering classes, you'll recognize some of the stuff we do there. Unit 4 then.
Question is being asked if Laplace transform is similar or better than L'Hopital.
Different. Completely different. Thanks. Yeah, I don't know why I can't have the chat showing while I am sharing my screen. Yeah, just keep interjecting though. I appreciate that. All right. What are we doing in Unit 4? Unit 4, we're going to use some linear algebra techniques, matrices, to solve systems of differential equations. Right? When you have two or more, we're going to be really just looking at two equations where you have two unknowns. But what happens when you're solving a differential equation? The unknowns are not variables, they're functions. So when you have a differential equation, it's got derivatives of a function in it, as well as the variable like y, y prime, y double prime, as well as x. And the solution to that differential equation is the function y, and that we could also call f of x. All right, so that's just a quick overview of the course. Review. Some of this you're going to just need to do on your own. So if you're fresh out of Cal 2, you're probably in the best shape. Do you remember integration by parts? Integration by parts is kind of undoing the product rule, if you think about it. If you've got the integral of a product, UV, which actually we write as U, where's my eraser? dV, where U is one thing, one expression of X, and dV is another expression of X, right? Oops. And if we can integrate dV, then that's equal to UV minus the integral of what? V du. Yeah, and usually pick dV to be the part that's easy to integrate, where U is the part that's easy to differentiate. There's also an acronym that I always used called ILATE. Yeah, see, that works too. LIATE.
You put the I front. Oh, okay.
Yeah, I learned it ILATE. And so apparently logarithmic and inverse trig functions are somewhat interchangeable.
Oh, don't tell me that now. I'm about to get
Oh,
mad.
sorry. But so yeah, if you've got both of them, it sounds like, you know, you can do either one. And this is how to pick U, right?
Yep.
So first, if there's any logarithmic or inverse trig, let U be one of those, right? It probably depends on the situation as to which one works best, but yeah, I always learned it the ILATE way. But here, I need to have my pointer here. Does this work? No. I meant to just circle that temporarily. So anyway, yeah, how to pick U, either inverse trig or logarithmic, because those are the hardest to integrate, right? They're not the best to differentiate either, but they're the hardest to integrate. Whereas algebraic would be next, like polynomials. Trigonometric would be next. Exponential, e to the x, a to the x would be next. So that's, you know, what priority, what order of priority, what preference for you. So if you have two expressions multiplied together, that's kind of the deal there. So let's see what time we got, 6:13. There is a document in our course called, let me just switch real quick to my other screen. That is in content. Where's my mouse? I lost my mouse. There it is. General information. This guy. And there's answers, but not solutions, right? So what you're going to want to do between tonight and Thursday night is try to do these, okay? Try to work these out, and we'll come together on Thursday and go over it, okay? So try to do those. Yeah, I'm just going to leave it there. And let's go on to the actual DE stuff. So for the actual DE stuff, there's a document under Unit 1, notes for sections 1.1 and 1.2. All right, so this is where we want to start going over things, and this is what I have, you know, in case you don't have the textbook. Again, this is kind of the what you need to know from the textbook. The background of, you know, differential equations being really important for engineering, mathematics. Yeah, you know, interestingly enough, I, as I mentioned, have a PhD in mathematics, but I never took a course in ODEs for my in my whole mathematical career. I had to take a course here at Trident Tech with Eileen Solomon before I felt comfortable to teach it. But that's one just point or evidence in how vast the field of mathematics really is. I went into a field called abstract algebra, which and set theory, which is looking at structures that have some of the algebraic properties of numbers, but not all of them. And what can you prove about these structures? It was all theoretical and logic based. So another testament to my not liking applications. The mathematics I studied doesn't have any, or if it does, they haven't been discovered yet. All right, but anyway, these things that we're looking at in this course do have lots and lots of applications. So that's what's cool about this course. All right, so here's some examples of differential equations. You can see you've got third derivative here. Second derivative, first derivative. So this one, because the highest derivative is the third derivative, we would call this a third order differential equation. And then this second one is a second order differential equation. And what's that third one? I guess that's a y triple prime. And then I don't know what this is. It looks like something didn't come through. Let me try downloading this in case that's a glitch. Sometimes if this is a document, yep, PDFs come through fine, but documents not always. Here, check this out. Yeah, look at that. That's different. It couldn't recognize any of this stuff. Yeah, if it's this was a doc file, Word file. So I might try to convert that to a PDF so you can see it just by clicking on it. All right, so derivative form of a differential equation is this guy right here, where it's got a dy dx in it. Whereas if you split up the dy dx and really just treat them as entities where, you know, you can multiply both sides of the equation by dx, right, to get it out of the denominator, then you can.
Can't hear you anymore.
Yeah, it seems like it cut out.
Oh no.
Class is over, guys. Move on.
Time to drink.
Yeah, I'm with it. I'll go back to work till Saturday. Shit, I'm in.
All right, it looks like we're all using GroupMe for the group chat.
Yeah, GroupMe's
Yeah, so, yeah.
pretty good one, and it works on all devices, Android and iPhone. So.
Okay. So, if you guys want to join the group chat.
Oh, is that what you posted there? That's the one?
I think so. Whoever. Thanks, Ethan.
All right.
I think she's still talking.
I'm gonna wave my hands. Maybe she'll see it.
Yeah, it seems as though she's gonna keep going on.
Oh no.
Wait, no, she looks like she looks like she knows their audio cut out.
Oh man.
Okay, I'm back.
Oh,
that was
there you go.
weird.
Hey, welcome back.
That was weird. It just it just all of a sudden muted me. Who did it?
Not it. No,
Sorry.
All right,
Sorry.
I'm gonna keep myself like so you can see me. All right, so let me continue. Where did I get muted? I was talking about
the derivative form.
the derivative form
form to
versus the
differential.
differential form. Okay. So yeah, you can just like multiply both sides by dx and go from derivative form to differential form. And sometimes one form is handier than the other form, all right? More examples are down here. Again, they're telling you what order based on the highest derivative, okay? Partial differential equations, I mentioned, just have those partial derivatives. We won't do these. The order is just the highest order derivative. This is big. You're gonna have some homework problems asking whether a differential equation is linear or not. And that's gonna be important to be able to recognize because there's different methods for if it's linear or if it's not linear. So ignore everything you know about the word linear. It has nothing to do with linear equations in algebra like y equals mx plus b. It's not related to that, okay? I'm not really sure why it's called linear, but that's the name they've chosen for it. And the shape or form of a linear differential equation is that you have these derivatives of y, and again, you can have any order of derivatives, but the coefficient of each derivative is, there's a typo in here too. The coefficient of every derivative is just a function of x. Oops, that doesn't need to be in the subscript. Okay, so each of these coefficients are functions of x. So an expression involving x times a derivative of y, an expression involving x times a derivative of y, and so on. And then it's either equal to 0 or it's equal to another expression involving x. Okay, so in other words, there's no y in with another y in as a product with another y. Okay, so you know, if you have y by itself, that's like the 0th derivative, if you will. That is only multiplied by something involving x. Okay. So when checking for whether it's a linear, LODE, the dependent variable, which is usually x, y, which is usually y, and its derivatives occur to the first degree. Now, careful about the word degree. I tended to get this messed up, but degree is power, right? Order is derivative. So you don't have any derivatives.
Say that one more time.
Okay, so order is derivative, whereas degree is power. Degree of an equation or of a term is talking about the highest power, whereas the order of an equation is the highest derivative.
So saying like second order, third order is the number of
that's
derivatives.
talking about derivatives.
Okay.
So for it to be linear, I guess this is why it's called linear. Linear has to do with first power, right? A linear polynomial equation is a y equals mx plus b type of thing. So there's no powers on derivatives. There's no power on y, there's no power on dy dx, there's no power on d2y dx squared, all right? Those are derivatives and they're all to the first power. Okay, no products of y and its derivatives. That's what I was saying, no y's multiplied together. And then no transcendental function of y and its derivatives.
Can you explain that last one a little bit?
I'm not sure why that's in there. Transcendental means not algebraic, basically. Algebraic is like polynomials and stuff. Transcendental is exponentials, logarithms, trig functions would be transcendental. Transcendental is just not algebraic. Okay, so there's one down here, I think, right here, cosine of y. Because there's a transcendental function of y, that's not linear. But it can't be linear. It can't be a algebraic function either. Because like this one right here has a 4th power on the first derivative. That's not linear. Also, this term right here has a y times the dy dx. So it's not linear for two reasons here. This one is linear because it's got a third derivative just with a coefficient of 1. And then it's got, oh, I take that back. That's not linear. That's got a y squared. That's not linear. If that was just y, it would be linear. Okay, so that's not linear. Let's look at this one. This one has an expression of x times a derivative of y, second derivative of y, an expression involving x times a derivative of y, an expression involving x times y equals, almost linear.
Wouldn't
So
that
far, good.
sign?
Yeah, we were
the
almost
sign
there.
X,
But then this is not involving x. Okay,
Wouldn't
so
that
they're
sign-
actually trying to show you all the counter examples.
Wouldn't that
Right.
sign X invalidate that too?
No, the sign x is okay. It's sign of y that's not okay.
Got it.
So this first one is linear, right? It's derivative, second derivative of y with coefficient 1, derivative of y with coefficient 5, and then y with coefficient 6 equals 0. This doesn't even have any x's in it. But, you know, in front of each of these derivatives could be an x or an expression involving x as well. So that's a relatively simple linear ordinary differential equation. And again, we usually don't say the O, we'll just say LDE or DE.
So
Right.
question.
Yeah.
The bottom one where it says, cosine of y.
Mhm.
So why is it okay to have, for example, sine of x, but no cosine of y, even though the bottom equation, all of it related to y actually?
It's because you don't want any of your dependent variable, the y, to be inside not only any transcendental function, but inside any power, right? The y and its derivatives can't be inside anything, all right? They have to stand alone with only numerical coefficients or an expression involving x in front of them. So the dependent variable and its derivatives occur to first degree only. And also the dependent variable is not in any other kind of function. Transcendental function, you can just kind of think of as other kind of function. There's no y inside a sine, inside a logarithm, inside an exponential, nor inside a power other than 1. And then no products of y. Okay, so you're really looking for what's going on with y when you're checking for linearity. Any function involving y is not allowed for linear ODEs. Okay, so there's a function involving y that's algebraic, not allowed, right? Whereas, here's also a function involving y, not allowed. You can have expressions involving x, any expression involving x, all right? So again, if this had been e to the x, that would have been linear. Actually, what I wanted to do is pull this into my, does anybody know about pulling a document into a course or into OneNote?
Yes, I'm using OneNote right now.
Okay, how do I pull this document into OneNote?
All right, as long as you have this document, you can either copy it, you can pull it in two ways. You can copy it, it just says the content, or you can save the document and then pull it in, and OneNote will not only read it, but then it will also make a little copy of it at the top of your OneNote document.
Oh, cool. Okay, so suppose I
Yeah, so you can save
suppose
that.
I save it as a PDF.
Yep, go ahead
Okay.
there. And then you're gonna go to, I'll do it with you because I'm on my OneNote.
Sweet.
And then you can go on the top there, you can go to insert.
Okay. File.
On your OneNote.
Mm-hmm. Insert
then-
file on OneNote.
Yes. And then you'll select the file and it'll plop it right where you want it to be, wherever your cursor is at OneNote.
Insert as attachment, insert as printout.
You could insert it as either an attachment or printout. Both of them will show. If you do it as an attachment, it will just show the attachment in the top left, and then we'll show all the document, all the words below. If you insert it as a printout, it just won't show the main document as a little icon in the top left, and it will just show all of your content. I would recommend going for the second one.
Okay. Let me do that again. Insert. Oops. Now it went away. Okay, so insert file. Insert as, I'm sorry, which one did you recommend? I tried to do the upload to OneDrive and insert link, and then I don't see where it went. Insert as attachment. Oh, I see it. But I want to be able to write on it. Can I write on it now?
In the OneNote, I can't see it, but you should be able to write over it. You might have to change the colors of your ink or whatever you're writing with.
So here I've got it pulled over, but it's just a PDF. See, I brought it here. Can you see it now in OneNote? I can't hear you talking. Jamal, is that you? You're muted.
There we go. Can you hear me now?
Yeah.
All right. Can you scroll down? It didn't insert itself as a whole. So then try the other option.
Okay. So insert file. There it is.
And then insert as printout. Still not showing.
Oh, there we go. There we go. Perfect.
Yeah, and you should be able to still write over it.
Yep. Good, good, good. Ooh, I like this. Okay, I can get rid of those later. All right, so.
Don't get rid of both. Just get rid of one of them. The one up top.
Oh, okay.
Near the bottom, you do not want to get rid of that.
This one.
Get rid of that one, yes.
This one right here, I want to keep.
No, you want to keep that, yes. And you want to remove the other.
Okay, so this one I could actually delete.
Yes, there you go.
Awesome, thank you.
No problem.
Okay, so yeah, this is better because now I can actually kind of show you what I'm talking about. So here, see what I want to mention was that we've got just functions of x, right? Functions of x, functions of x, function of x, which means just, expressions involving x. Oops. Could be anything. X only. Okay, no y. No y. All right, so this one is a linear ODE, but it could be something like x squared d2y dx squared plus 5x minus 6 dy dx plus ln of x times y equals e to the x squared, right? Because I've got function of x, function of x, function of x, function of x, and then just the derivatives involving y are kind of untouched, all right? And this one is good except for this, right? It would be linear if it were equal to e to the x instead. And then this is the problem here, right? You can't have y to a power. This is the problem here. Well, the 5 is okay, but the derivative, you can't have derivative raised to the fourth power. But this is a problem as well. Y times its derivative, you can only have X in front, product of Y and its derivative. And then here, this is a problem. Can't have, basically you can't have Y or any derivative of Y inside anything, any function. Hopefully that, does that make sense? All right, so solutions. Where does it say what a solution is? I had mentioned that. The solution is really just,
It didn't show it prior to what you showed us.
yeah. Yeah, the solution is just the function y that satisfies the equation. So there's types of solutions. Explicit is, if you remember, when you learned implicit differentiation, explicit means you can solve it for y in terms of x. Whereas implicit is when maybe you've got something like x squared plus y squared equals 5, you know, like a circle. Parametric is when you've got something like x is a function of t and y is also a function of t. Right? That would be a parametric set of solutions, family of solutions. Some examples, yeah, y equals some constant times cosine of x plus another constant times sine of x is an explicit solution for this one. In fact, let's check that. What is y prime? If this is y.
Sine, crap.
Derivative cosine of x is negative sign, right? And the
yeah,
constant, that coefficient just stays. So it'd be negative c1 sine of x.
And
And
then
then
positive cosine or positive C2 cosine x.
you got it. All right, what's y double prime?
That would become negative C1 cosine x
Good.
minus C2 sine x.
Excellent. Because the derivative of cosine is negative sine. All right. So now what we want to do is plug those in. Okay. So y double prime plus y, is that equal to 0? Well, y double prime is here, negative c1 cosine x minus c2 sine x. If you add that to y, which is c1 cosine of x plus c2 sine of x, voila, everything cancels out and you get 0. That's supposed to say yep.
Okay,
All
this
right.
is what I was stuck up on in the book. I was confused, but all right.
Really?
Yes.
Gotcha. This next one?
No, thank you.
I'm sorry?
No, thank you.
Oh, okay. So the x squared plus y squared equals c, some constant, is an implicit solution because y is kind of mixed in the equation. Solution to x plus y times dy dx equals 0, which by the way is not linear, right? This first one, this is linear. But this one is not linear because of that product. Oh, I keep doing that. That product of y times its derivative.
Wait.
All right, so what?
One question.
Mhm.
So that even though it includes y and y double prime, it's linear because the y's aren't attached to an x or being multiplied by
It's because
x?
they're multiplied together. It's because the y and the dy dx are multiplied together. Right? Remember, you can't have any products of y and its derivatives.
Okay.
Yeah. Yeah. It takes some getting used to, I know. You'll have some of your homework problems will test you on it so you can do it and redo it. So
Dr.
here's,
Pavane?
yeah.
How soon do the lesson videos, like where you're talking right now, how soon are those uploaded to the class, like for us to review?
So it takes a few hours for them to process. I will get an email when it's ready. And I'm not sure, I am kind of a late night person, so I probably will, I'll try to get it posted tonight, but it might not be till tomorrow morning. But I have an office hour Wednesday and Friday mornings at 9 o'clock, when if I don't have anyone bugging me, I can always post it.
No, it's totally fine. I just, you know, there's just bits where like it just goes a little bit too fast. But
I hear you.
But
Yeah.
I just wanted to make sure like you post them, I guess, to the regular dashboard of
It'll be under content.
Oh, it'll be under
Yep.
content? Okay.
Yep.
No worries. I just wanted to make
Okay.
sure you do upload them, and that's
Okay.
totally fine. Thank you.
Yeah. So one thing that you'll be doing in this first chapter, though, is just verifying, checking that something is a solution. And so that's what's going on here. They're checking or verifying that it's a solution. And that just involves plugging it in. It's not something that's easy to put on a test, unfortunately. Although I can, you just have to show what you're doing.
Question.
Yeah.
Real quick, I'm sorry for interrupting again.
No
so the x plus dy dx is not linear because of that y dy dx, yes?
Correct.
All right, thank you.
Yep. So that being a product of y and its derivative is not allowed. All right, so what I was going to do is kind of show you what's going on each step here. So they're checking to see that this is in fact a solution to this equation. So what they're doing is they're doing implicit differentiation. Remember that? The derivative of x squared is 2x. The derivative of y squared with respect to x is 2y times dy dx. And then the derivative of a constant is 0. So then solving that for dy dx involves, let me do this over here, involves what? Subtracting 2x from both sides. Let me put up a wall here. And then dividing both sides by 2y. Ugh. Stupid button on this pen. So if you divide both sides by 2y, you see how you get negative x over y. So then it says, okay, now substitute that in. What are we substituting it in? We're substituting it into the differential equation. X plus y dy dx equals 0 is the differential equation. Substituting the derivative in for dy dx gives you this. Canceling y gives you this. X minus x is 0, and it checks out. Okay, so if it says to verify that something's a solution, that's what they want you to do. You take the equation, take its derivative. Like for this first example, that was an explicit solution, so we could take its derivative and second derivative explicitly, whereas this was an implicit solution, so we had to take its derivative implicitly. Right, that's implicit differentiation. To get that derivative and be able to substitute it into the equation. So once you get the derivative or whatever's involved in the differential equation, then you plug it in and make sure that it satisfies the equation, that it comes out true. All right, ready to go on?
Bring it on.
Boy. Oh boy, initial value problems. So initial value problems are usually when they give you an initial value, that's how it gets its name. Like when x or t is 0, what's y? Okay, which is usually given as y of 0 equals some number, right? Equals 5 or something, for example. Here, they're actually giving you not an initial condition, but another condition, right? They're actually giving you a point, 212, which is sometimes written as y of 2 equals 12, right? You've definitely seen it as f of 2 equals 12.
Why would they do that?
Because that's what they're going to do to you now.
That ain't right.
I know. So y of 2 is the same thing as f of 2. Sorry. They just don't want to bring f into it. They just want to keep the function name as y. So if y is f of x, then we could say it's f of 2. Well, we don't want to call it f of x. We want it to just be y. So they say, well, let's just use this notation then, y of 2, which is going to be the same thing as f of 2. So yeah, but it's like you're given the point, 212. Do you remember, and this is where I wanted to show the page, the first page in chapter 1 of your textbook shows parallel curves. Do you remember when you first learned anti-differentiation and, I'll put my face up here again. You first learned anti-differentiation and they said, okay, there's, for each function, there's really infinitely many antiderivatives, right? There's the prime antiderivative, and then any constant could be added because the derivative of a constant is 0. So when you take the antiderivative, there could be this constant. We just don't know what it is. So there's really infinitely many antiderivatives that all differ by a constant. So if you graph those, you've got a bunch of parallel curves, right? So like the antiderivative of 2x, for example, here, I'll draw this, right? Let me do it over here. So for an example, if y is, let's say y prime, so that it's it's here. That's actually this. No, that's a second derivative. Okay, so for an example, if y prime equals 2x is your differential equation, then y equals x squared is one solution, but any constant could be added. And so if you look at how these antiderivatives differ, you've got the generic parabola with vertex at the origin. Well, if you add 2, for example, remember how that shifts it up 2? Whereas if you subtract 3, for example, it shifts it down 3. And so all of the solutions are just parallel curves. So that's why having a point nails it down to which curve you want, which constant, okay? So the idea is when you solve a differential equation, you're going to get a general solution that involves one or more arbitrary constants. Whereas if they give you an initial value problem, then that's going to be where they give you enough information to find the specific solution, the specific function that goes through that point. So here you can see what they're doing is they're giving you this differential equation, which really just involves taking the integral of both sides. And I'm not a real fan of this notation right here. I would rather write this as the integral of dy dx equals, can I make this bigger? The integral of 4x cubed dx, because you really are supposed to have that dx on with your integral.
Is that Leibniz?
Mm-hmm. And also this guy right here, you can see the dx's kind of cancel. It's actually by definition that that's equal to y prime, but you can see that this is the same thing as the integral of dy. And if you put a little 1 in there, you can see that the antiderivative of 1 with respect to y is y.
Y.
Plus some constant. So here they've got y, but technically there's some constant on one side and another constant on the other side that just get combined into a single constant. Right, so I would say if you have y prime equal 4x cubed, you know, we could say that y, the antiderivative of y is x to the fourth plus some constant, sure enough. But if you integrate both sides and use this notation, you really would technically have a constant on both sides. All right, so you get this general solution. When you have a constant, that's called a general solution to the DE. The differential equation. Whereas then when you have an initial value problem, like I said, that allows you to then find the specific solution. What is that constant? By plugging in 2 for x and 12 for y, right? There's y, there's x, plugging in 2 for x and 12 for y, and solving for c gives you the specific solution, which they should have written down. I guess they did. Yeah, initial value problem solution. Ooh, bad page break. Sorry about that. That should have been on, that should have been up here, right? That the solution y equals x to the fourth minus 4 is the specific solution.
Question for you.
Yes. Go ahead.
So is it generally through this course that we're going to be generally prior to now, I'm assuming a lot of us have been able to get by with, you know, plus C, is that's what we're going to be breaking down, and there isn't going to be a constant anymore. We're going to figure out, or at least figure out exactly.
So what I'm trying to show you here is there's the two types of solutions, okay? So if they just say solve this differential equation, you're going to want to make sure that you have that arbitrary constant, okay? Whereas if they give you an initial condition or a point, function value for a specific, you know, given x, a specific value of y, then you can plug those in to get your specific solution. So sometimes the general solution is going to be all they ask for. You just have the arbitrary constant, a lot of times, in fact. Okay, so you just have to see what type of problem it is. So IVP is the abbreviation for initial value problem. That's when you're given a function value, basically. A point or a function value, value of y for a given x. Let's look at this second equation, second example. This is a second order DE. This one is written in terms of f of x, right? We could also write it as y double prime equals 2x, right? Or we could write it as d2y dx squared equals 2x. All right, and this one is nice and explicit, so you can just, again, take the antiderivative of both sides. The antiderivative of 2x is x squared plus some constant. So here on the left side, you go from second derivative to first derivative, right? When you take the antiderivative there. So then, since this is second order, you actually need, and in fact are given, two function values. Right, two function values are needed for second order DEs to get the specific solution, to get a specific solution anyway. You could always get the general solution. In fact, let me show you what you get if you didn't have any initial conditions, right? These are initial conditions. Those are actually true initial conditions when x is 0. what is the function value at initially and what is the derivative initially. And when x is 0, that's like at the beginning. So if you just have y double prime equal 2x, the antiderivative would be x squared plus some constant. But I'm going to write that as the first constant because we're going to have another one when we take the second antiderivative, right? Antiderivative of x squared is 1/3 x cubed. The antiderivative of a constant is that constant times x. And then there's another constant, right? So each time you anti-differentiate, there's an arbitrary constant that comes into the picture. So this is actually the general solution to that DE. Now, since it's an initial value problem, they stop here at the first derivative and solve for C by using this piece of information, right? That the first derivative when x is 0 is 1. So notice they plugged in 1 for f prime or y prime, 0 for x, and they solved for C to get C equal 1. They plugged it in. Then they took the next antiderivative of both sides and got that the function y or f, I don't really like this notation, but is equal to this plus, another arbitrary constant. And then given this initial condition, right, this is that f of 0 equals 10, plugging in 10 for f or y and 0 for x gives that constant equal to 10. And so this then becomes the specific solution to that initial value problem.
So a question for you.
Yeah.
If we did this as what we've done before, we would be able to just find our general solution, plug in the values for what we need from what they're demanding, and then that's our specific solution.
Yeah, I'm not sure I understand the question. I'm sorry. Like you're asking, could you do this and then plug in these values?
Yes.
That's a good. I
You
don't
figure out the general
so.
solution.
You
That's
really
what we
do
did
have
in
to do
Cal
it in
2.
steps. Yeah.
Cal 2, we always redid the general solution, and then we plugged in what values we needed to, and that found us our specific solution. So
True.
those
So it's
steps.
the same thing. It's the same thing, except for did you do second order, or was it always just first order?
I'd have to defer to some people who are my
So yeah. So when you do second order, you really want to stop at each step, because second order means you're going to be taking antiderivatives twice, and you're going to want to stop at each step to find the arbitrary constant that's involved.
Yeah, most of what we did last semester was all first order.
That's what I would think. Thanks.
Thank you, Sherry.
All right, so then on your handout here, it has the existence and uniqueness theorem, which I don't even like the way this is stated. On my notes, I wrote that this theorem is stated much better on page 17. It's called Theorem 1.2.1. It's not really necessary that you look at that, but if you're interested, I would say go to the book to see a better statement. I think this is somebody's, I didn't create this sheet, but it's somebody's kind of summary of it. But it talks about the existence of a solution if you have these certain conditions of continuity, and if you have a partial derivative that's continuous at some point in the domain, then there is this solution that they call phi of the differential equation. That's really just y. Y is phi of x. On some interval, this is an inequality that talks about some interval around x0 minus h to x0 plus h is exactly what that's talking about. Actually, what they put it at less than or equal to. So that's what they're talking about. Whoa, that just went away on me. Are you guys still there?
Still here.
We're here.
Man,
here.
I hate these things. I never
Here.
know what's gonna happen. Thanks.
Yeah, still here.
Oh gosh. But anyway, long story short, there's theorems like this that are really important in pure mathematics. The whole theory, I should say, theoretical mathematics. For practical speaking, if you have a practical situation that has a solution, the techniques you're going to be studying in this course are all you need. You're going to be able to find the solution. All right. What else? What else? What time is it? We have 15 more minutes. Now, usually we'll be giving you a break. For some reason, didn't today. I apologize. If you guys need a break, we can always turn off the recording and take a break and pause the recording. So that's something I typically do.
I know a few of us are doing a study group, and we might have to scroll through some messages to find the right group me message that was left in your chat there.
So I can post that when I when I go to the recording. In fact, for my calc class, I got a chat file. They just gave me a chat file. So I'll find the chat file. And
I don't know if everybody wants their numbers that they posted chat on a permanent record though. Yeah, some people put the number to everybody.
All right. Email me if you don't want your, actually, you know what? Email me if you don't want me to post that. In the future though, don't share something in the chat that you don't want posted, okay? I mean, it'll just be posted in D2L, so it will just be private to our course, okay? It won't be like it's on Facebook or something like that. It'll be inside the course, so there is that amount of security. But I do want to be able to post everything. All right. So I'm trying to look at my notes to see what else we need to talk about. Does anybody have any questions?
No.
So yeah, there's separable equations. When are we going to deal with separable? That's not till chapter 2.
Hello.
Good. Okay, so yeah, this first chapter is really just what is a differential equation, verifying a differential equation. What is, verifying the solution by taking derivatives and plugging it in. Looking at initial value problems where you're given these conditions. Yeah, I think we've covered everything except for the whole reviewing of, let me turn this back up, reviewing of the integration, right, that I want you to do on your own first. So really work on not only the WebAssign for chapter 1, 1.1 and 1.2, which should be pretty easy. What's a linear equation, what's not, and these relatively simple differential equations where you just take antiderivatives. And then look at some serious reviewing of integration, because that's gonna come up. Yeah, so that's again under content, general information. So yeah, what I'm gonna do, and I'll just show you here, is I'm gonna create another module here that's just class recordings. And I'll go ahead and put it for unit 1. And then I'll move that up so you can all see it. It's going to be up here. How about right after the documents? So Unit 1, Chapters 1 through 3 is full of documents, and then you'll have the class recordings. So I'll upload it right here, and I'll post the chat file, which will just be a text file, as long as I can find it. And then as long as, you know, I can actually delete anything that you want me to delete. So just email me about that. And then the notes that I've written here that look a little messy, but for better for worse, I'll post them. All right. Any questions? Let's call it a night. Yeah.
Actually, I do have a question.
What's that?
You probably said this like a bunch of times. So what's so for Cengage, right? So I'm looking at it right now.
Okay.
And it says that there's an option to buy the textbook, and then there's an option to buy Cengage Unlimited.
Okay. So you want the unlimited.
Okay.
Yeah.
You
Because
said
it
it
should
was
say below
100.
there that, I mean, you want to make sure that you get WebAssign. So the unlimited is what contains WebAssign. Yeah, that is kind of weird. I agree.
Wait, okay, so it says pay for materials individually, and that's 100, and then the Cengage Unlimited is 120. Is that the right one? I just want to make sure I'm getting the right one.
It should be 100.
Yeah, that's the one that has the WebAssign, which you need.
I'm pretty sure, like, for me, I'm only taking this one class, so I only needed to buy the stuff for this one class online, and it gave me WebAssign, so I don't think you have to. I'm pretty sure that Cengage Unlimited thing is like if you have multiple classes that you need stuff for. I think you can buy like just the one class's stuff separate from everything else, though.
You're absolutely right. Yeah, unlimited is different than something else. Yeah, you're right.
So just buy the $100 one.
Okay.
Yeah, pretty much.
Yeah.
Okay. Gotcha.
Yeah.
All right. Thank you.
So this is the link. Let me post it in the chat. It was in the announcement. So if you, that went to someone privately. Hang on, everyone. Let me try that again. Paste. That's a site that she made specifically for us. You'll see it says Trident Technical College. Welcome to Math 242 Differential Equations. So yeah, there's the Cengage Unlimited. So scroll down. That's what I didn't do.
Yeah, it's the two
Scroll
options.
down. That's the key.
Yeah, the two options that you want to be looking at are the two at the bottom. So you pick one of those two. One of them comes with like the loose leaf version.
That's where they are. I was wondering where they went. You know, scrolling down is a lost art, right?
Oh, there you go. Yeah. Gotcha.
Yep.
And the website instant access for the. Okay. Gotcha.
Everybody got it.
Mm-hmm.
All right. Yeah, the one for $100 is the best. Just getting the WebAssign, and the one for $145.95 is with the.
Listen, we're good at math. We're not good at reading. Two different things. I'm good with math.
Well, and then there's mathematical reading, which is a whole different thing.
Oh God.
I don't even want to. Nope.
Oh no. All right. Well, good luck getting going with it all, and we will open it up on Thursday with questions on the review of integration and questions on chapter 1, and then we'll jump into chapter 2. Thanks for your help and your attention.
Will you be able to go over any homework questions that we have?
Yes.
All right.
Yep.
I already got a few for you.
Oh boy. Write them down.
It's gotten better now that I got through the lesson.
Yeah, write them down as opposed to saying, you know, this problem on this page, because WebAssign, it generates these different ones. So so write down what the problems are that you have trouble with that you want me to work out.
Thank you.
Sure thing.
So it's really
all right, going.
See y'all.
Thanks. Night.
Gone.
So is
Bye.
it really? So is it really Cengage Unlimited?
No, it's WebAssign Instant Access. Are you on the site, Andre?
No, it's Michael.
Michael, sorry. Michael, are you on the site?
Yeah, I'm on the site.
Scroll down. See where it says WebAssign Instant Access?
No.
Did you see the link I put in the chat?
Oh, hold on. Let me see. Okay, I see it.
Awesome.
Which one is it? Cengage Unlimited?
Nope, scroll down.
Okay, I'm scrolling down.
WebAssign Instant Access.
WebAssign Instant Access.
Yes, sir.
It's just $100. Okay, I found it. Thank you.
Yay. You're welcome. All right, have a good night.
Okay. Yeah, you too. Bye.
Bye.